Hey, what's up YouTube? It's BeetlePlayer1011 here today, and we have another math lesson. And this one is on a very important limit, and I'll just be focusing on this one for the entire video. And this one is on the following limit, that the limit as x approaches 0 of sine x over x equals, and we'll find out that it is equal to 1. Now, in the limits that we've been covering before, they've been pretty simple, things you could just plug in. But as you notice here, if you plug in 0 into sine of x, you get 0. And then if you plug in 0 into the denominator, you also get 0. And 0 over 0 is indefinite. And obviously that's bad for our case. So we're going to go through a special limit that involves the squeeze theorem. Now, to review what the squeeze theorem is, I covered it in my last video, but quickly, it's just that we have to take two other functions, one that is always greater than and one that is always less than this function, and when they're equal to each other, we know that logically this function must also be equal to that same number. Now, let's look over here. I've drawn what we call a unit circle, meaning that the radius from the center to over here is 1, and the distance between here and here is also 1. So the radius of the circle is 1. And out of this, we can get a few things. So first, let's talk about this length over here, this line. The length of this line, well, it's a unit circle, so let's find that this over here is actually going to be equal to sine x. Because sine x, if you remember from trigonometry, is equal to opposite over hypotenuse. And the hypotenuse is just 1 for this triangle, so this side over here is just sine x. Now, I want to find the area of this triangle over here. If I draw a straight line between here and here, almost goes along the curve, here and here, and then here. Now here's the reason. The area of this triangle is going to be 1/2 base times height, as the area of all triangles are. The reason why I've extended this triangle is because I want the base to be 1. And the base over here is 1 because it goes from here to here, and that's the radius of the circle. The height is what we just found, sine x. So what we end up with is 1 times sine x over 2, which is sine x divided by 2. Now, let's move on. The next area I want to find is the area of this curve. So, this curve extends a little bit out from this triangle. There's a little bit of space in between, so the area is a little bit larger. And so it's basically a sector, this sector of the entire circle. And the measure in radians of this angle is x. So for the area of this sector, what we're going to do is we're going to take a ratio. So we know that the area of the entire circle is going to be pi, because the area of a circle is pi r squared, and r is 1. So it'll end up being pi. Then we multiply that by x over 2 pi, because x is the sector that we want to find, over 2 pi being the degree in radians of the entire circle. So we're going to multiply that now by x over 2 pi. And this turns out to be really nice because we can just cancel these out. What we end up with is that the area of that sector is x over 2 for some angle x. Now the last one I want to find is, and I'll do this in yellow I guess, the area of this outside triangle. So I know it's getting a little bit messy, but this triangle over here. So we know that it's 1/2 base times height, and we know that our base is 1, but our height is this over here. And what we're going to find is that this height is actually equal to tangent, and I'll show you that right over here. So you should be able to decipher from this that we're going to end up with something with a similar process anyway. Tangent x is equal to opposite over adjacent, and our adjacent is 1. Therefore, we can just, if this is 1, then tangent x is obviously just the opposite. Meaning that the area of this final triangle, I'll call it area 3, is equal to 1/2 base being 1 times height, which is tangent, so we end up with tangent x over 2. Alright. Now that we have all of that, we can set up an inequality, knowing that this is our smallest, and this is our largest. So let's do this in black over here. We know that sine x over 2 is less than x over 2, which is less than tangent x over 2. Now this will only be true when they're all positive, so what we're going to do is we're going to take the absolute values of them. Okay? And I'll be dropping them later just to make it look a bit easier, but you'll see why this is true later. And we're going to do something, just going to cancel out these 2's because they all have them. Our next step is a little bit tricky. We're going to divide everything here by sine x. So sine x divided by x is just 1. That is less than x over sine of x. That is less than tangent over sine of x. So what is tangent over sine of x? Well, that's actually pretty simple. So tangent x is sine x over cosine x. So the sine x's will just cancel out, right? So let's just show that over here. We have, going to simplify it, sine over cosine, and then that's all over sine, meaning that these 2 cancel out. So we end up with just 1 over cosine. Now I'm going to rewrite this here. 1 is less than x over sine of x. Which is less than 1 over, make this bigger, cosine x. Okay. Now, we're going to take the inverses of them, and what's going to happen to the inequalities is that they're just going to switch. And I'll show you what they mean on the side. So, in yellow, think about it. If I say that 1/2 is less than 2, if I take the inverse of both sides, I'm going to have to say that 2 is greater than 1/2. So, what I end up with basically is that 1 over 1 is just 1. So 1 is greater than sine x over x, and you should be seeing what's coming up now, which is greater than cosine of x. Now I dropped the absolute value signs because this is only true on these first 2 quadrants when they're both positive. So if we think about it, in this quadrant, the first quadrant, sine x is positive. In this quadrant, it's negative. X is positive and negative in those quadrants as well. Meaning, so we get positive over positive, that's positive, or negative, which is positive. So we're only talking about negative pi over 2 to pi over 2. Coincidentally, it's also the same quadrants where cosine is positive, because remember, cosine is just the positive end of the x-axis. So all of this, first and fourth quadrant, are positive for cosine x. Now, the limit approaching 0. The limit approaching 0 for 1 is 1. The limit approaching 0 for cosine x is 1. Therefore, this must also be 1. And that's our answer. And just to verify it, let's look at the graph over here. As you can see, this is sine x over x. This is 1. This is cosine x. They both come to 1. Sine x over x crosses 1. As you can see, this actually goes a little bit further. Over here and like over here, this is where it's where this inequality was true. Over here I know it crosses, but that doesn't matter. We're only talking about it around 0. Thank you for watching.